understood how we can go ahead and find roots to a certain quadratic equation. And the way we do that is we basically have a quadratic equation, let's say in the form ax squared plus bx plus c. We put that thing equal to 0 because we know that's where the roots are. That's where the quadratic equation touches the x-axis. And so once we are in this form, we know that all we got to do is we got to turn this into the vertex form, or we got to turn this into the factorized form. And then all we got to do is we just got to solve it, and then we'll get the values for x, and those basically are going to be our roots. Now, there's actually a third way you can go ahead and find out what your roots are. And basically, by using that method, you don't have to convert your quadratic equation into vertex form or into the factorized form. You can just use this thing right over here directly, and you can get your roots. And basically, the equation for that is, it's basically minus b plus minus square root b squared minus 4ac over 2a. This entire thing is called the quadratic formula. So this right over here is called the quadratic formula. And what this thing over here does is that basically you got to take this standard form of your equation, and all you got to do is whatever your b is, you go ahead, put that b over there, right? And then also put your b in there as well, because that's another b. And then you put your a in here and also in there, and then you put your c in the place of c, and then you just solve it out, and then it basically spits out two answers. One is going to be for the plus sign of this square root, one is going to be for the minus sign of this square root, so you're going to get your roots. Now this is basically known as the quadratic formula, and I'm going to go ahead and do a problem for you. So let's say we have a quadratic equation. Let's say it's 3x squared plus 6x plus 16. Okay, so let's say this right here is our quadratic equation, and we're trying to find the roots. So what do we do first? Well, we got to put this thing equal to 0. That's what we do first. And now what we're going to do is we can either convert it into its vertex form or its factorized form, but we don't want to do any of that. We just want to use this quadratic formula, and we want to solve it that way. So I'm going to write my quadratic formula. It says minus b, okay? So we're going to put the b in here, and the b is equal to 6, so we're going to put the 6 in here. And in fact, let's say it was negative 6 over here. It was negative 6. Then what are we going to put in here? Well, then we're not going to put 6, but we are going to put negative 6 in here, okay? And then we are going to have plus and minus, and then we're going to have the square root. We're going to have our b, which is minus 6. We're going to square that. We're going to go ahead, subtract 4. And a is 3, so we're going to put 3 in there. C is 16. We're going to put 16 in there. And we're going to divide all of this by 2. A and a is 3, so we're going to put 3 in there. Now, I'm going to solve this out in my calculator. I'm just going to put this entire thing in my calculator. Do it once for the plus sign, then do it again for the minus sign, and see what my answer is going to be. So give me a second over here. This is going to be, so we got this thing, and then we got, hold on, guys. Give me a second over here. Okay, so the first root that we get is actually, oh, actually, never mind. This equation turns out to have no roots at all. So this equation actually has no roots. From the quadratic formula, from this quadratic formula, I've basically gone ahead and found out that I don't get roots to my equation. And the reason I can find that is because if you put this thing in your calculator and you solve it out, you're going to get something that says math error. You're going to get something that says math error. And that math error basically means that your quadratic equation has no roots, which means there are you're basically in a problem where you have your smiley face all the way up here, or it could be up here, or it could be up here. It doesn't matter. Point is, it's way above the x-axis, so that's why you actually have no roots. And how do I know it's a smiley face? Well, because I just looked at a, and a is positive 3, so it's of course going to be a smiley face, and that means the smiley face is probably above the x-axis, which is why it never touches the x-axis. So sometimes you can just use this formula, right? It's better for convenience. You don't have to convert it into your forms, your vertex form or your factorized form. You can just go ahead, put this thing in your calculator, press equals, and then just go ahead, change the sign over here, press equals again, and then you'll get the other root. If you have no roots, you're going to get the math error in both of your tries. Also, side note, if your calculator is in complex mode or something like that, then you may see a symbol that is going to be this. So you're going to have something, and then it's going to have this symbol next to it. It's going to have an I symbol next to it. Now, if you see this thing, that basically means that you have no roots. So either you're going to get a math error, or you're going to see the symbol, and either of these means that you have no roots to your quadratic equation. Now, there's a quicker, simpler way to judge this, and you don't really have to use your calculator for that, or even go ahead and solve out these problems. You don't have to go ahead and solve out your vertex formula. You don't have to solve out the factorized problem. You don't have to use the quadratic equation. There's a faster way to actually know if the quadratic equation you're going to be drawing is going to have roots or not. And you can basically judge that before even drawing out that quadratic equation. So how do you do that? Well, it takes on this idea that the quadratic formula is basically this thing, minus b plus minus square root b squared minus 4ac over 2a. So you take this quadratic formula, and the idea is look, this is how I can know if my quadratic equation has roots or it doesn't have roots. And how I judge that is basically I look at this thing right over here. Now this entire term, b squared minus 4ac, it's going to solve out. If I plug in all of my values in here, my values for b, my values for a, my values for c, it's going to solve out. I put this in my calculator, it's going to solve out, and it's going to give me a number. Okay? And that number If that number is negative, then that means that my equation is going to have no roots. And you may ask, well, why is that? Well, because have you ever seen a square root? Have you ever seen a square root with a negative number? With a negative number? No, you have not. Square root, you can only take square root of positive numbers. You cannot take square root of negative numbers. And so therefore, if you get a negative number inside of your square root, that means that no answer is possible. It's almost like saying, okay, divide 3 by 0. Have you ever seen anything being divided by 0? We know that that's not possible. And in the same way, we cannot have our square root and have a negative number inside that square root. That's not going to happen. We need a positive number over here. That's something we can take a square root of. But a negative number is something we cannot take a square root of. So that means that this b squared minus 4ac, this term that we had right over here, this needs to solve out and give us a positive number. Only then are we going to have roots. Because otherwise, if it's a negative number, then we cannot solve out this quadratic formula. And if we cannot solve out a quadratic formula, then that just means we don't have any roots because it's impossible. The formula is not being solved. We cannot solve it. We cannot divide 3 by 0. So we don't have an answer, and so we don't have roots. So what we're trying to do is we're just trying to check this b squared minus 4ac form. And this b squared minus 4ac, this thing b squared minus 4ac, this actually has a special name. It's called the discriminant. So it's called the discriminant. And the discriminant has to be a positive number. It cannot be a negative number. So how do we go about this? Well, this is how we go about this. I'm just going to show you guys what we're going to be doing. We just go ahead and we take this b squared minus 4ac term. So we take this b squared minus 4ac term. Now we know this thing is going to be under the square root. Under the square root. Square root. So this thing actually has to be equal to, this thing has to be a positive number. It cannot be a negative number. So what we do is we just solve out this b squared minus 4ac term, and in this quadratic equation, if I just take this quadratic equation and put that in here, my b was actually negative 6. I took this quadratic equation, I solved out this quadratic equation. So my b is going to be negative 6 squared minus 4, and then my a is actually 3, and my c is 16. So I'm going to solve this out. We know what negative 6 and negative 6 is. That's just going to be 36. So 4 times 3 is basically 12, and then 12 times 16 is going to be 192. And you can clearly see we're going to have a negative number. When we solve this out, we're going to have a negative number. And we cannot put this thing in a square root and solve it out. That's going to be a math error. So no roots. And so our discriminant is negative, and so we have no roots. So we have three possible cases. We have three possible cases. Remember, we were like, our quadratic equation is going to have a smiley face or a sad face, and we're going to have three possibilities. We're going to have either, we're going to have one root, or we also call these real and repeated roots. Repeated roots. Then we're going to have two roots. We also call them real roots. Real and distinct roots. That's what we call them, real and distinct roots. Real and distinct roots. And then we also have imaginary roots, right? Or no roots. So no roots or imaginary roots. Imaginary roots. And see, we don't really have to plot a graph every time to see this, and we don't need a graph to check this out. We don't have to turn our quadratic equation into a smiley face or a sad face and then draw a grid and see, okay, is it here, or is it here? We don't have to do that all the time. Now, just using this discriminant right over here, and the fact that you cannot have a negative number under the square root, we can use this idea and we can be like, okay, well, if our b squared minus 4ac is a negative number, then obviously that means we don't have any roots, and so it's going to be this third case. So if b squared minus 4ac is a negative number, which means it's less than 0, then we basically have no roots or imaginary roots, right? If it's a positive number, then we're in this scenario right over here. If it's a positive number, then we have two real roots, and that's just going to be b squared minus 4ac. How do we say it's a positive number? We say, well, it's greater than 0. It's a positive number, which means it has to be greater than 0. And what's the case where we only have one root? What's the case where we only have one root? And well, that's the case, we call that case b squared minus 4ac is equal to 0. And why should it be equal to 0? Well, we'll check this out. So remember, our quadratic formula went something like this. So it was minus b plus minus b squared minus 4ac over 2a. Now imagine if this inner term b squared minus 4ac, all of this just gives you 0. Then what's going to happen? What's the square root of 0? Square root of 0 is going to be 0. So then you're going to get plus and minus 0, right? Which basically just simplifies to the quadratic formula being minus b over 2a. And all of the other stuff that for b squared minus 4ac is going to vanish because it's 0. So then this thing right over here is only give you one answer. It's not going to give you two answers. The only reason you're going to have two answers is, let's say, if you have a b squared minus 4ac term, well, and then it gives you something like, let's say it gives you 36. Right now you take square root of 36, you're going to get two answers. You're going to get plus 36, you're going to get minus 36, and therefore these are going to lead you to your two roots. But when your b squared minus 4ac term, your discriminant is equal to 0, that means you just have one root.